Was I?
Start recording. Okay, so we are in the middle of a side quest because in terms of recording we were doing modules. So and now we are just finishing something else. We are finishing a rewrite on the parser because now we are using recursive descent. Uh, but because it uses we have higher order functions, our recursive descent parser looks more like it reminds me of parser combinators. Cool.
Well, it kinda is, but it kinda isn't because it's following peg semantics.
Yeah, I don't know the difference between those yet. I just know that looking at it, it definitely looks like combinators at some point, in some points. Which I actually thought of something. Why do we have the if then else? Wouldn't it be easier to make choice instead?
The
Choice
problem with
parser.
choice, like normal choice without the then, right? You just have the if and then you have an else. It's basically a nor, right?
Yeah,
Um,
in the you.
the problem is tail calls. You don't have tail calls in that case if you succeed.
Um,
And that matters because I have a parser here that's a loop, but it's a conditional loop.
I have a loop.
Yeah, this one, see?
I still don't think this matters. Only in Marinho's world not having tail calls is a problem, isn't it?
Well, it is a problem because this is parsing a list, right? And
Mm-hmm.
if this loop here was not in tail position, then you would require space proportional, well, extra space proportional to the length of the list to parse the list.
Yeah, no.
Like,
Uh, we would have to rewrite that, but I still believe choice is better because we're gonna have the top level parsers for queries, directives, and declarations. They are just a bunch of choices with more than two choices, so if then else is gonna suck.
it won't actually. Here's an example with multiple armed if then
Yeah,
else.
that's exactly the situation that I thought. Okay, yeah, a choice would be better here. There is more boilerplate in this code in comparison to a choice. So with a
Um,
choice, you would only
there,
have
there
the
really isn't
integer variable
because
funcs, and then
no,
map
there
values are
really isn't.
there's f maps, right? So this is just f map.
No, there really isn't, Lemos, because like if we were using choice here, um, actually we can do that just so you see how it looks like. Okay, so this can go like this, I think. What's the problem? Oh, right, I need an actual composition operator here. So,
Yeah,
like this.
it would be a list of parsers, right? So it would be integer variable func list.
Not really, because the then is doing work as well. You can't just get rid of it.
You will not delete that. This is just fmap, man.
Uh, actually, this is in fact supposed to be like this, I think. Mm,
Well, I have no
yeah, this is not.
idea if these
Yeah, this is
operators
not quite
would be
right.
there. Um, but like I said, it's not actually like I think it looks worse by not having choice, but it's essentially the same thing. So to me, it's okay. It's okay. Like I don't have a problem with it.
Ah, no, I think I got it. It's because like this, but then we have to get rid of the OKs here. And I think this might be Okay, and this is maybe result.
Yeah, I'm not familiar with the operators that you created in the meantime, so I won't be able to help you that much. But like I said, it's fine. Like we don't have to do with the choice just because a bunch of ifs and else's in as parser primitives. Usually people use choice for that instead. But that's okay. That's okay. That's completely fine. Like for example, if rewriting the loop would be like way worse, we can keep it. That's fine.
Well, if you're not familiar with the operators, I guess I should start by going over them real quick. Um,
No,
where
no, you already
is?
went through that, but I don't have the practice to memorize them properly.
Okay.
Um,
Okay.
well, but if it ends up like if later I want to pick a use choice, I can just take a look at the code later and see if, how can I make that happen. Today we just want to get it done, right? So we'll
Okay.
have functors, we have func labels as well. Remember you mentioning that?
We can parse expressions, like flat out. We have an expression parser.
Yeah. Yeah, so this is gonna probably gonna be this expression parser is gonna look like it's gonna be similar for the other umbrella parsers like the declaration, directives, and things like that. But we're gonna use different inner parsers, of course. Okay, so which one do you want to start with? We have queries, we have directives, and we have declarations.
Queries directive and declarations. Let me see. EST. Um, we should probably start with declarations because they are the simplest. Actually, queries would be the simplest technically. Let's do queries. Let's do
Sure.
queries. Um, parser clause F. Yeah, so basically a query conjunction is a list of functors, right? Essentially.
Yeah, with location.
Okay, so let um, query uh, let me grab this type signature here. Equals, and we're gonna put a placeholder here for now. Okay, so it's a list of functors with locations, so we need to change this type to list.
Yeah. And then let's just do use that, and that's it.
Hmm. Okay, actually, actually, queries and declarations they look kind of similar because they both start with a functor. So we're probably gonna merge them somewhat. Let's do something like I don't know.
First func.
Um, let's assume we already have the first one parsed because then we don't have to duplicate the common part in the other parser.
Sure. That works.
Okay, so
Uh,
this will need to take a functor with location and it's going to return a parser. Make sense?
yes, that's fine.
Okay, so fun. Um, first, um, first element, I guess. Arrow. Okay, so we have a first element. Um, and we need to construct a list, but actually it's easier to turn the list, to turn this thing into a list only, oops, only at the end. So to begin with, let clauses equals batch finger tree singleton first element in. Okay, and then we need to. Actually, do we need to do this? Probably not. Um, Probably not, but okay. So after the first element, we have two options. We can either have a comma, which means there's at least one more clause, or we can have a question mark, and that means that's the full query, right? So in
Yeah.
fact, let's do the base case first. If then else, do we have do we have question? We don't. Okay, colon. I kind of feel like rewriting some of these later, but let's not do that right now. So let question mark equals one question mark. If question mark, then that's the end. So if question mark, then we should in fact return.
Wait, this is the base case you said, right?
This is the base case, yes. Actually, we're gonna need an accumulator, won't we?
Yeah. Okay, so
Hmm,
because this is a query conjunction, you're parsing a single query right now. That's it.
I'm parsing. Yeah, we have the first clause, but we need to decide what to do after that. So if we see a question mark, then we're done. So we just need to return the result,
The accumulator.
which is going to be. Uh, well, this is going to return a unit. We don't care about that. And then we need to return. I have a return. Okay. A return first element. Return first element. So what's the problem here? This expression should not be a unit. Oh, right. That's because fun fail with to do. I have to do this, otherwise the type system is going to complain that that's not. Hmm.
Okay, so it's complaining. Wait, no, there is a difference in types there. Parser state, func. Oh, okay, so
With
it's not returning a
location.
list.
Oh,
That's the
right. We need
problem.
to wrap this. That's the problem. Okay.
If it's
So if we
not a
have a
question
question
mark,
mark, yeah, we have this. If it's not a question mark, then that means, in fact, that we need. What do we need? We need.
If it's not a question mark, we need to try to parse a functor, right? Because that's what what's immediately before the question mark is.
We need to try to parse a comma, actually.
A comma.
Yes, because the first functor here is given, right? What comes after that if it's not a question mark? It needs to be a comma.
Ah, I see. No, I forgot that we already have a functor as an argument here. No, that makes sense.
Right, so this is going to be a list where okay, list off. Do we allow a trailing delimiter? We don't. The start delimiter is going to be
A comma.
skip white space and comma.
Yeah. And then the middle thing is gonna be
Skip white
functors.
space, comma. Then the separator is actually it's actually going to be skip white space and comma as well. So let's make a binding for that here.
Mm-hmm.
I don't want to write this twice. List of sep, and then the final one is actually going to be. Wait, do we not have comma already? We do actually.
Mm-hmm. I think just because we need to finish list off, so just put functor as the thing in the elements of the list, right?
There's still the close delimiter. So this is skip white space and then question mark.
Wait, I didn't get it.
And then this
What
is
is?
for the. Okay, there are three
Ah, no,
things
the
here.
the inner parser is the last argument. No, then never mind then. This is at the
Yeah,
end
no.
delimiter. No, this makes
Yeah,
sense.
yeah, because those three tend to be simpler. The last one can be pretty complicated sometimes,
Sure.
potentially. Also, the three first ones, they all return unit, and we don't care about that because that carries no information content. But the last one does. See? Um, Real quick, just to check the types to do. Okay, what's the problem here?
Has type parser.
Okay, this is a parser, and this is also a parser. Um, it needs to be a parser of unit, and this is a function from a parser state to unit, which is in fact, well, um,
Mm-hmm.
let's just say whatever. Okay, so what's the problem here?
That's not how you do unit, I think. You need to write unit.
Hmm.
Yeah, so the problem is that whatever this you did there, maybe the combinator in the middle is wrong. It's making this a function and not exactly a parser. So I wonder if the operator in the middle is the correct one.
It should be, because this is what we use for. Yeah, this is for functions that. This is basically monadic composition on result.
Oh, but
And
then but this returns a lambda, so that means that the type of sep is wrong then. This returns an a to another thing, not a parser.
But a parser is just what you get when you instantiate that h to a parser state.
Don't know if I buy that. Yeah, just keep that as. But an expression is expected of type unit parser state that type parser state is incompatible with this.
Ah, right. Actually, we need to ignore the unit that comes from here. That's the
Yeah,
problem.
yeah. So that it was the operator. Nice. Okay, so now what's the problem?
Hmm.
Um, this expression has type. I couldn't read that in time. Start the limb, separator, and the limb. When an expression is expected of type parser state.
Are we missing an argument still? Um.
No.
Ah, yeah. I added labels to that. That's why. Start the limb and the limb, and this is in the limb. This is separator. And let's rename this to space, comma, because that's more descriptive.
Yeah, but it's still mad.
All right, because we need to eventually convert this to the result of list to, because this returns a finger tree.
Ah, okay, so it's because you already are setting the outcome type of query, and it's not a finger tree.
Yes,
Yeah,
that's not a problem.
just fmap the outcome of this to list, you know?
Yeah, that's not really a problem. Let me just say, okay, let me put this here. So for now, we can do that. That means we need to do mapl. Actually, no, we need a parser here.
Yeah, I noticed that you're using a function called replace on the other case there.
That's to ignore the current, well, actually not really to ignore, it's to convert the replace. Yeah, this is to convert the left element. Actually, we can just do this. Um, we can just do this. Let me say, I thought like that this is not implemented. Let's do that first, actually. So this
No,
needs to
yeah, just copy
be
paste the case
a,
we used the replacement. I think that's exactly what we want.
this needs to be a func, but then we need to do replace with bat finger tree to list, and then we need to, no, actually this is afterwards. This
Yeah.
is in fact afterwards.
Yeah, so it's exactly as the other case that you were using replace. Cool.
Okay, so the types line up now, and then we still need to do one more thing, which is,
One more thing.
yes, after we convert the parse result of this list to an actual list, we need to add the first element because that's not there yet.
Yeah, but you're gonna use a cons for that, I imagine.
Indeed, indeed. First element. This doesn't work, does it? It would be too easy if it did.
No, yeah, that doesn't work. But let's see if there's a cons function. Let's make the bet. Is there a cons function? Oh, there is. Okay,
Of
so
course
you
there is.
okay, so you probably can do that. These two replacements are composable.
Uh, they are, I guess.
Okay. There's an extra parenthesis there. Okay, so we have a query, right? Because this is essentially saying, hey, either you are done and then you just do 4 through 3, or you just do the non-base case, which is to do the list and then you add the first element to it.
Yup. Hello, Tevo.
Hello. What else do we need for queries?
What else do we need for queries? Actually, I think there might be a slightly more elegant to do this, but no, this is it. We just need now to, like when we set up the parser for the top level of a file, we need to, like the idea is we're going to look for either a holds or a functor. And if we find a functor, then we need to match either a query or a declaration afterwards.
Sure. So what are we doing next? Declarations?
Yeah, let deco, let's call this, let's do a proper word.
So I'm assuming the type signature of
Let's,
this is going to be pretty similar.
indeed. Uh, so again, we're assuming we have the first functor already, and this should return, in fact, um, this should return, in fact, deco here,
Yeah.
which is this. So we have the head. We need a list of functors as the body. That's easy enough. So
Yeah, we just made that.
yes, except we still need one more detail. We need to parse the.
Holds.
Yes, we do. Comma. And then
You didn't make a string parser. You're using like you're composing the char ones. Interesting.
I mean, I didn't need that until now, so that's actually one of the things I was thinking about. Yeah, maybe we should have that, but
That can be
that would
done
be an
later.
improvement. That can be done later. Yeah.
Okay, so the first thing we do, well, first of all, line 435 should actually be a deco and not a func, right?
A deco. No, the deco is going to be the output.
Exactly. So it should 435 is incorrect.
Oh, actually, yes, you were right. Do we have a location around the deco? We don't because.
No, we kind of do actually. Because remember, we don't deal with base, we deal with t's, and t's have the location.
Okay, man. No, we do need the
Same applies for
deco.
query, by the way. Remove list as well, by the way, in 435.
In 435. Yeah, we don't return a list of decals, we return one decal. So the
Yep.
start delimiter is going to be the holds. It's going to be the holds. Actually, there may be white space in front of that. So skip white space, holds. That's the
Yep.
start delimiter.
Yeah, perfect.
The separator is going to be, yeah, it's
Commas.
going to be this. It's going to be this. And the end delim is
It's
going
gonna
to be a
be
dot.
dot, yeah.
Again, skipping white space.
We should probably make skippable versions of these token parsers.
Actually, no, I'm doing this backwards. I was following up here the convention that we skip the white space afterwards. I don't know why I changed that. Ah, it's because for list that's more natural to put the skip in the front. Okay, never mind.
Mm-hmm.
Mm, okay, what's the problem? Ah, parser. This is actually going to
Nah,
be.
yeah, but this is a parser clause, yeah. We haven't do the. We need a replace after. We need to fmap this, so it doesn't matter this right now.
Okay, so we're going to need functors, right? That's all we need, in fact.
We just func there. Yeah, and now we do the replace. First, replace the.
Oh, actually, fun head.
Mhm. Mhm.
We need the head. That's a problem.
Yeah, but do the same. So convert to a list the finger tree. We also need that.
Met finger tree
Yeah.
to
And now,
list.
yeah, and now we're gonna create the decal. Um, Now we're gonna create the decal, but here's the thing. Here's the thing. Everything needs to. Let's just start with a location add lock, because remember the output of this that needs to have location. We're gonna use the location of the head anyway.
We're going to use the location of the head. Add lock.
Yeah.
Okay, so this is going to give me a list of functors with location. So we need to do
Yeah, this is a body. No, no, no. This is a body. This is already perfect as it
this
is
is
as a body.
this is what do you mean?
The output of 444 is gonna be the body, right? If you look at 105 on the right, what we just
Yes,
parsed is gonna be the body field of the record, right?
you are correct. So actually to list and then after we turn it into a list we need to
Grab the
I
body,
guess
and now we're gonna location.add lock because the outcome needs to have location as well. Uh, you can skip the yeah that, and then just grab the location out of the head to upgrade to the location of the declaration. Yeah, exactly. Yeah.
okay, so what's the problem here?
Unused variable. What? There's something very wrong.
I know why. I think
I'm not so
so
sure.
this is a func.
Which is correct for the head,
This is a list of funcs with location.
which is also correct for the body.
Ah, return. That's not right. It's already composing. So in fact, oh yeah, no, that's the problem. The problem is no, this is inside of replace.
Yeah, this is inside of a replace. I wonder if it doesn't have access to the parser clause module namespace, and that's why it's fucked. Like it doesn't know how to create the record because of the it doesn't know how to it doesn't have access to parser clause. Yeah, but then do equals head maybe. No,
No,
that was
this
not
is
it.
supposed to this is supposed to work.
What is the problem?
Unbound module parser clause. Ah, I know why. It's because this is in fact AST not parser clause.
Ah,
That's the problem.
okay. I think that's it. We have a decal. We have a decal.
We have a decal.
And there will be some gymnastics though later, because here's the thing. We only the location that you are adding on the decal in the return type, that's gonna be for the T type, not the base. But we need to make a parser for base first. You see what I'm talking about?
A parser for why?
Because because what do you mean why? That's the type, right? We have to make the base first and then do the T later, no? That's how it's written in the type definition there.
I mean, we could just do the T directly because here's the thing. This decal here, right, is this one.
Yeah.
The correct conjunction that's above is going to be this one.
Yeah, but
We
we're
need
not
to
to.
parse a directive, and then the parser for the top level is going to be responsible for actually calling these parsers and then converting them into a base, but then they already have a location, so they need to be the base inside of the location needs to be, or rather, the payload is supposed to be f mapped into a base, but that's already with a location around it, so it's automatically a T.
It's not, because it doesn't have the declaration tag on 98. That's what I'm calling gymnastics. Somebody is gonna have to do that, which is not this parser.
It isn't, no. That's not really, it's literally just an f map.
Yeah, no, but I was imagining that we would make a base parser for the parser clause that would do that for us. It's directives.
Directive.
Yeah, directives now. Okay, so let's think a little bit. Yeah, this is not gonna work. Directives is a mutual recursive parser with T-man.
Is a mutually recursive. No, it's just a list of functors.
No, it's not.
Ah, no, it's a list of functors and a T list. It needs to be recursive. Okay.
Yeah, but
So
we don't
actually,
have the
the
T yet.
top. Okay, so actually. Okay, that's interesting. So. Uh, top level. Uh,
Parser clause.
yeah, we can just call it parser clause, no?
Sure.
So this is going to return, in fact, a T.
T. Yeah, just that. And then we need to do a choice. But in this case, we're gonna use a bunch of if then else's, right?
Yeah,
Because we don't
so
have choice. So it starts with anybody, and then do the same thing that you did for expressions, essentially.
I mean, we do have choice. It's just it's implemented in terms of if then else, or rather, it's an or. It's not really a choice because it's just binary. It doesn't take a list.
Yeah, that's why it's more annoying in my eyes.
Um, okay, so first of all, we need to not do this because we don't need to presume we already have something.
That's true. Very true.
So first of all, we skip white space and
Yeah.
comments.
Uh huh.
Actually, yeah, we should have done this all along for those two.
Uh huh. Uh huh.
So we skip the white space in comments. Then there are two cases. There are two cases. Either we have a holds,
Yeah.
in which case that's a new thing.
would say let's create above
Let's do
this parser clause, let's create the directive with a fail with body just to have the types line up.
the directive.
Yeah, because the directive and the parser clause they need to be mutually recursive, right?
They do, kinda, yes.
Yeah, so I would say just make the directive type signature so we can have something just to do the Tetris with the types. And then we could go back to this thing.
Let me do the else first because we don't have to bother with that. Uh,
I guess that also works. Yeah, so
okay,
you
so
grab the
if we have a
func, the
hold,
first, yeah, if you have
yeah,
a holds, we're gonna do later. If you don't, then
we, have a,
it
we need to have a
must be,
func.
it must be a func in the beginning, and then it's another if then else, right?
It must be a func in the beginning, and then
We need to try for another if then else, either query or declaration.
yes, we do, but we need to. Actually, we're already skipping white space in those things, so yeah, we can just do
If then else.
if we have a func, then if we have a func, then um, we have a first and we have the state. I'm kind of tempted to make a function that does this, so we don't have to mention the state every time because that's kind of annoying actually.
It's no, it's opening the abstraction. Uh,
Okay, so I guess we can do
no, it needs to be an if then else though. It needs to.
query first or declaration first.
And this is not enough. You need to fmap the outcomes of these inner parsers with the tags, with their correspondent tags.
Mm, yeah, we do. And then
No, this R is doing the if then else, so it doesn't matter. You need to fmap this parser, this query parser.
mapl mapl we need to do.
This will
And
return
this is
to
kind of
us a
annoying.
func with location list, right? Just add the
This will
tag.
be,
Just add the tag to it.
yeah, let me just do this, okay? Um, let query of Q be a query conjunction of Q.
And there's another problem. We are missing a location because here's the thing. We have locations inside the query conjunction, but I need to wrap that query conjunction with more location. How are we gonna do that?
There.
That should not work.
This expression has type, but it was expected to be.
Yeah, this is returning base. This is returning base, and that's not gonna be enough for us. You need to add location, my man. Fmap doesn't work here.
But query already has. Wait, it doesn't, does
It
it?
doesn't. It has location in the inner elements of the list. The list itself doesn't have it. which is the problem.
Okay, that's easy enough to fix though. Although that means we need to know the starting location as well, don't we?
Well, but the first functor has location. We can try to use that, no?
We totally can. Okay, so we const the first element onto the list, but then we also need to do location.
Add lock.
And this is kind of annoying because it takes the location
Yeah, you're
last.
gonna have to use flip function. I think it's inside fun. Man, this is looking very much like Haskell codebase.
What did you expect?
Fun.flip. Oh, you're not gonna write the flip using the compose. You're gonna do it by hand. Sure.
I'm gonna do it by hand because I learned something kind of annoying. Apparently, the functions from the fun module they don't play well with universal quantification.
Ah, I see. That sucks. That's it. Just first element dot lock. No. What I'm confused. No, just first element dot lock, man.
No,
I
that doesn't include the location of. Oh wait, no, but that's the header, no? That's the convention we're following, right?
Okay, so why this is broken, I have no idea.
Hmm.
Mm, what is the problem? I could not read that. That was fast. Too fast.
Hmm.
This expression has this type, but its expression was expected of the type there. That's doesn't make sense to me. Yeah, it doesn't make sense to me. Why this expression? What is the type of L in the fun?
It's a list with location.
Yeah, so just add location to the list itself. What's the problem? This is an fmap type of operation, so it doesn't need return. I am confused. I am extremely confused. What is the problem? Do you see?
I don't really.
Can you put parentheses on form 20 just to make sure? I don't think that's the problem, but no.
That's not a problem.
Man, what the fuck?
Hmm.
It was working before. We know that for a fact. This expression has type parser state, but an expression is expected to have this type. But that's wrong. Why is it saying, but an expression is expected to have the second type? That's not the type that we want at all. It's removing the with location that you just added to the type signature. You see?
This expression has this type.
But an expression is expected of this type. The expected is wrong.
Hmm.
Do you see that it doesn't have
I
double with locations?
I do see.
Yeah, that makes sense, the error message, but then it doesn't make sense why the expected type is that, for starters.
Mm, so we take a func with location. If we get rid of this, and it says that this is a problem.
Which is, in that case, this is wrong. This line. This line should be removed because of that type. And I think if you remove
In,
it, it works actually.
it does.
Does the second argument, there's a question. Does the second argument of if then else also does not need location? That's it. Thank you, Tev. We're stupid. Both branches of the if need to match, Marinho. And line
Ah, okay.
424 doesn't match. We're just retarded.
Okay, that means we need to do something like this whole thing needs to be replaced like this. Right?
Yeah. Does that work?
It does. It type
Uh,
checks.
there are some red artifacts in the screen sharing here. So I can't tell if it works or not. Thank you, Tev. Thank you, thank you, thank
Thank you, Devo.
you. Okay, let's continue. So the parser clause. Yeah, now this should work. This mapl that you wanted. This should work now. Oh, actually it won't, right? No. It will. No, it will, because you're doing location.fmap. Yeah, this should work.
This expression has this type, but an expression was expected of that type.
That's peculiar. What's the problem? This expression has type this. I couldn't read that. But an expression was expected of type this. I think this is confusing. This is confusing the type system because of the 459. I think we need to finish 459 and then it's gonna be happy. Well, removing it should also do the trick. Yeah, so what's wrong? Can you Dune build this? Okay. So this expression has this type, which is correct.
Ah, it's because there needs to be a replace, not a mapl.
No.
And this needs to be this. Yeah.
Okay. Okay, now we need to do the OR, which is for the declarations, which is the same thing. Same thing. I don't follow. That's not gonna work.
Hmm. Then we need to do the declaration.
Which also receives first as an argument. And it also has a mapl, but we need to construct a declaration instead of a query. You probably need to do the same with 458. Do the directive as well already. We're gonna do the same trick most probably.
Most probably. Just 1 second, I wanna fix this.
Yeah, it's the same trick that we did below. So just use the the operator in the middle there. No. There is a parenthesis
Actually,
problem. There is a parenthesis problem.
parenthesis problem. I'm using at already
Ah,
though.
no. If you're using the if then else, there needs to be a predicate sort of parser. No, that doesn't. No, you're right. You're right.
Okay, this goes from A to B, and then I need a function from A to C. From A to C, that means actually I don't think I need this. Mm,
Seems still
almost.
wrong.
I need to do. That's not what I wanted to see. This has a type from func list with location to parser clause base. Oh, this needs to return a parser. That is correct.
No, so just use
That
return
means
then.
return is for injecting a return value. That's not quite what I want.
This seems to be exactly what you want. You want to grab a function and lift to a parser.
It isn't.
No, yeah. I don't know if that's gonna fix our problems with the types. Oh, it's closer. Okay. So, huh.
You know what? This actually. Why is mapl not working? This is not compatible with AB result. Oh, I know. It's because of this actually. I forgot. We need to do result. Okay. At the end. Because it's really annoying.
Not enough. Apparently. Oh, now it's enough.
There.
Cool. 459 at the end should not be query, should be declaration. No, but you named deco instead. Yeah.
Let's use proper words.
Sure. Cool. Okay, so just LSP being crazy now. Okay, now we need to handle the fail width on 453.
Now we need to handle the fail with. That means, in fact, that okay, if we parse a holds, we need to parse a functor because that's what comes after the holds when we have a directive.
Yeah.
Then we need to parse a list of parser clauses, which is delimited by curly braces.
Yeah. Yeah, just do a
Um,
let directive and let's create this parser and make it mutually recursive with the parser clause parser.
and in fact, this entire thing needs to also be followed by a dot. This entire thing needs to also be followed by a dot, which means I need to do basically this
Hey,
um,
why we're doing this?
dot and I don't think I have a dot, do I? I don't. This is the wrong
Ah,
file.
this is the ending of the thing.
Oh, I do, but it's called something else. It's called period, not dot. Uh, there.
Annoying, but okay. Okay, let's go. Let directive. Let's make let directive now.
Okay, so if we get the holds, We can ignore the unit, and then
Just call directive parser.
directive parser.
Yeah, we're gonna have to write that, but I think that's it for this one.
We don't really need to though.
Oh, you want to do it in line? I don't like that, but sure.
We need to parse a functor and then
List off.
yeah, you know what? This is really annoying. Let me actually do that capture operator because it's bothering me every time I look at that. Actually, did I already do that? I don't think I did. Parse loop, fail. Oh, this is the old version of the. Okay, so new parser. Replace map and inject. We have maybe. Yeah, let's put it here, I guess. Let capture is going to take a function. It's going to take the
An outcome of a parser, I believe.
the parse result and the state, and it's actually just going to
F state.
it's actually just going to do f result state.
Yeah.
That's it. Okay, that means we can do capture. We don't need this, and we don't need this anymore.
Yeah, the types are not matching because there's no fail width on 457. The types are not matching because of 457.
Okay, so now what?
Now I think the types are matching, but something's wrong. Um, is the operator at double arrow? Is that giving us the outcome? Oh, same thing. Yeah, same. Yeah, actually that doesn't need. That works. Okay, so cool. So do you want to make the directive parsers inlined? Is that it?
Uh, I kind of do because it's just a list of.
I think that hits readability, man. If you ever want to change only directives and nothing else, you're gonna have to get around the noise of the parser clause.
I guess.
Yeah, so the type of this should be very similar to. Let's go to the AST module and let's see what we're gonna have there. Can you go down? All the way down? All the way. All the way. Thank you. So it's that's it. It's that plus an extra with location.
Yep.
And if you want to be consistent, we should not do the tag here. We should just do the tag in the parser clause, as we are doing for query and for query conjunction and declaration. And this should just be the inner contents of the thing. This
Actually, this should be a T list, and this should be a.
func with location. And the entire thing needs to have a location as well, by the way. Same
And
reasoning as the ones above.
Hmm, that means.
This is going to be a replace with location fmap and parser clause.directive. Yes. Are you sure it's the double arrow? ast.parserClause.directive, which doesn't exist yet, but it will. Cool.
This is failing though.
I think LSP is just going nuts.
It expects 2 arguments. What do you mean?
I'm so confused right now. What do you mean? I don't understand what's going on. Do you?
I have an idea, but I hope it's wrong.
No, but that's
I
bullshit.
was right. Yeah.
No, but that's very bad, man. Why why OCaml does that?
Yeah, this is
Terrible.
very sad. This is very
Terrible.
sad.
Okay, let's write the directive parser because we're pretty close. We are freaking pretty close. Actually, not really, because there's no error messages in this shit whatsoever.
Mm,
Okay, so the first thing we gotta do is to actually do the...
huh, that's still red actually.
Doesn't need to be rec, I believe.
I know why. It's because if you have a let rec, you must use a fun in here.
Oh, that's success. Okay, so the first thing we gotta do is to grab the functor, right? The first functor.
Uh, yes, it is. But actually, we have a holds, which means
Which means
which means let's do this first and then directive.
we need to ignore. No, you need to ignore the unit. So that's not the operator. Yeah, I'm getting, like, I'm learning. I'm learning how to talk this dialect. This Marinho's word of operators. Okay, so functor first. So that's what we should start with. Just func. Just func, not functor. Yeah. And this is gonna
Uh,
be, I don't know, header. Yeah, sure. After we have that, what we need to do is call the parser clause in a list fashion. So list off.
mm, yeah, actually, let's just do this. Oops. List of, and then the start delimiter is going to be left curly brace.
Yes,
The separator
is a space. It's a bunch of white spaces. I believe we didn't put commas between the curly braces, right?
list of. Do we actually need this list of here? Actually, we don't.
What do you mean?
But it's kind of silly, right? Because this is for a single parser clause, right?
Yeah,
This is for a directive,
sure.
but then we still need the parser for the whole file, right?
No, it's because a file it's a bunch of parser clauses, right?
Well, yes, but that means we can do this, in fact.
I still don't get to how we're gonna remove the list off from here. That's 100% not clear, but top level.
Do we need locations there? We don't, actually.
What do you mean?
Like
Ah,
around the
no,
top
no, no,
level.
no. Around the top level, no. After you have a list of t's, you're done. This is not gonna fly though, because you need to put the header in the top level outcome of the top on the thing there.
I need to put the.
You need to grab the outcome of the top level and then use the result of that with the header.
Oh, yes, but one second. I need to.
You're just creating a tuple actually.
I need to do this, otherwise the types are gonna bother us significantly. And then, yeah, so after we parse the functor, we need to parse the top level, and then,
Grab the result of the top level and use you pick the header and make a tuple, and that's it. Oh, and add location. Add location. So this is a location.add lock. That's by the way. The
okay.
surroundings, right?
Um, that means actually we kind of do. There's a slight problem though. Top level can't just. It can't just be here because it needs to stop at a curly brace. Hmm. Okay.
That's
It
true.
needs to stop at a curly brace. But there's something we can do. So left curly brace and top level.
Mm-hmm.
Then we capture that. Oops. Then we need to parse a right curly brace.
Mm-hmm.
And then we can do what we want.
Which is just create a location.that lock, right?
Yeah.
Essentially. You need at before that. Yeah. So the element is going to be tuple header comma body for sure. And then the location is going to be header.lock probably.
Yeah, that's not quite right because the location should include the entire directive, not just the
Yeah,
header.
so probably going
But
to have to construct a location by hand using the start L and end L. And then we need to grab some pieces of both portions.
yeah, let's not do that right now though. Let's put a to do here. Um, Declaration, query. Actually, for queries, is this a problem? Oh, it is actually. So, to do for the composites below, um, the location around the result should um, encompass the entire text, not just the first element. And of course, the formatter doesn't break the lines in the comments for some reason.
And what's wrong, by the way?
What's wrong is this takes two parser states. Why?
Mm, curly brace, top level, another capture, grab the body. What's the type of the header and the body?
Location dot location. Hmm.
What's the type of the header and the body?
The type of the header should be.
Oh, it's not telling us. This expression has type location.t, but an expression is expected to have type location.location. Ah, the func parser doesn't have the locations that we care. It only has half of it.
The func parser only has half of it.
That's what it
No, this is
seems,
with
right?
location though.
Hmm. Ah, but do you agree that the error message there is saying that this expression has type location.t, but an expression is expected of type location.location?
Location dot location.
Yeah, location is the one with the both ends, right? Start and end.
It is,
And
yeah.
the t is just half of that. So header.lock is only half of that, which is I don't understand.
That makes very little sense because this returns a func with location, right?
Can you put a type on the header on 483? Put a type for the header. This should be func with location, right?
It should be.
What does... Try to run again the compiler.
Same thing.
No, it doesn't... It doesn't matter what's the type of this thing. I wonder why.
Hmm.
Oh, this tells you. This it doesn't.
Wait, this is a parser state. That doesn't make sense.
So that's the problem. This should not be a parser state. This should be an outcome. Are you using the double arrow? It should be double arrow.
It should be, because this returns a result. This is monadic composition over the result.
Doesn't seem to
And
be
this
though.
and this expects the left side of the
No, no, no,
result.
no, no. But, uh, but go to the type signature of the double arrow. The A is parser state in this case, right?
No, the A is a pair with the
What?
parsing output and the parser state.
Hmm. It's not really clear to me.
Okay, here are the relevant types. Okay.
Man, I think I know the problem. You see 47 there?
Yeah.
Lock is location.t, which is exactly what we're doing down there, header.lock. So header is parser state, which means that it is something is wrong in this line 4882. No.
Hmm. Okay, so we have the state. We're passing it to the func parser. Then we're doing a capture. Header is a parser state.
Yeah, that's the
How?
problem. This is definitely the problem. I have no idea how that's the case. Put parentheses before capture and at the end of the thing. Does that matter anyway? No, 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 that's wrong. The parenthesis is not correct place in 485. It should be on 484, the parenthesis. No, no, no. Then we go back to the what we were, man. There is put a parenthesis in 482 before the capture and after top level.
And after top, that doesn't make sense, but okay.
Okay, almost there. Uh, I see why you said it doesn't make sense. It's because the header, the scope of header needs to be everything else. Needs to be everything else. Yeah, no, 484 doesn't need the parentheses. You're right. 484 should not have parentheses at the end there. It should be there. But then the capture is still fucked. Whatever it is, we are doing something silly. Yeah, that didn't change anything. It's still a partial state. Huh. It's still a partial state. What's the type of header now? Nope.
Still a parser state. That's very weird.
Run the
It shouldn't
compiler.
be.
Yeah, it's still a partial state. It's still a partial state. Hmm. We're doing something very weird now. I don't understand what it can be. We're grabbing the state. What's the type of state? Parser state. That's the type. And then we're passing that to functor. What's the type signature of func?
It's a parser,
It's
which
a
is a
parser.
function from the parser stage to a result that
Yeah,
looks like this.
but we are doing the double arrow for the monadic, so the result is gone, which means there is only a parser state. And capture dismembers the tuple and only allow us to deal with the result, right?
Yes, it only allows us to grab the left part of the tuple, which is the result of the func. Yes.
What's the problem? Uh, what's the freaking problem? I am extremely confused. We have a state, we have a func. Immediately, like immediately on 483, we should have the func, but we don't. So something is composed wrongly here, and I don't understand what it is. I have a question.
Yes.
462, what's the outcome of if then else?
What's the outcome of if then else in here?
Yeah. No, not that. Why I'm asking this? 465, it's exactly our situation, right? You parse a func, and then we have a first on 466. That is a func with location, right? Can you check that?
This is a func with
Okay,
location,
so
yes.
this means that I'm starting to guess that it's actually the input to func that is fucked up. Because here we are sending state to it. But what are we sending on the other case that works?
State, or rather, the output of this.
Which is what? A parser?
Well, this is a parser, but it outputs unit, and we're ignoring it. So in fact, this if then else is gathering a parser state.
Yeah, but what is the input that we are sending to func on 465? That's my
A parser
question.
state.
So it is a parser state.
Yes. Like these type checks. Okay, if I comment all of this, the error we get is that the output doesn't match, but the input is correct, you see?
No, I didn't read. This expression has type blah, which is which is what we would expect. But then I don't understand. On the one above, we are doing at double arrow and then capture. Like, what the fuck is going on? You see? This no, that cannot be the case, man. That this matters.
I'm
This
just
does.
going back to how it was because there's less nesting. Visually, I mean.
Yeah, but the type of header is still parser state in this one.
It's inferring it as parser state, yes.
Okay. Dune build tells the same story.
You know what I'm gonna do, actually?
Tell me.
I'm going to
Put a type here.
put a type here, yes. For
Yeah,
all
that makes
A,
sense.
for
Well, it
all
doesn't make
B,
sense that OCaml's type inference will not be able to pull this
for
off.
all errors. This needs to be an A, B parser. And we don't need this variable actually, and this should be E. Okay, what's the problem?
Unclosed open
Don't
parens.
tell me you can't use for alls in here. Okay, for all errors, this takes an AE parser. It takes a parser. Then it takes a parser. Hmm.
Wait, what are you
It
trying to
takes a,
write?
actually this doesn't take a parser. This takes a
Function.
function. Yeah, this takes a function from. Okay, we do need a B here. So this takes a function from A to a parser of B.
What? No, man. The, the function only took result and state, and that's it.
Then it returns a parser of B to E. Um, actually,
I'm extremely confused. We were receiving an f and a tuple, and the f you're describing is a bunch of parsers.
actually,
Yeah, I don't follow.
from A to a parser, which is a function from a state to the result,
Which is already
and
not
then
correct.
it takes an A and a parser state,
I'm back.
and it returns um,
Hello, Mageta.
Let me see what you guys are doing now.
Type Tetris, essentially.
Type Tetris.
Yeah.
Is there a championship for it?
Marinho is the king because he's already familiarized with the operators, but I'm getting there. Like right now, Marinho is trying to write a type signature for a function that we did because apparently the OCaml time preference is not pulling this off. I think this is not correct at all because the f that Marinho is writing is written in terms of parsers, which was not the case before.
well, it was the case. It was just inferred.
It was not the case. The case was receiving a result and receiving a state. That's it. As far as it goes for inputs. I have no idea how the lambda here is going to receive something different.
It's not receiving something different. It's receiving the same thing. F is a function that takes an A and takes a parser state and returns a result of a B in parser state or an error.
Yeah, I don't. Let me try to explain how I see it. F receives two arguments, right? So line 102 should
Look at the
receive a parser
definition of a
state.
parser. Look at the definition of a parser, Lemos.
No, 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 I understand what you're doing there, but I don't see. I think it's better for readability to just have it exposed in this case. It's gonna be less confusing. And then you're receiving the parser state there as another argument, right? With an A, parser state. And then the outcome of that is you Does that actually work in OCaml? You don't need parentheses to do this type of thing.
You don't.
Okay, so doing f result state actually does the currying automatically. That's what you're telling me.
Actually does the currying
Fascinating.
automatically. Okay, this definition has type, which is less general than. Wait, it's assuming that the parser state is the error result. That makes no sense whatsoever.
uh, can we try doing the parentheses just to see if my monkey brain can keep this up? So,
You want
Monkey
the
brain.
parentheses. Okay.
no, not those parentheses. I mean on 105. Because again, you're doing the currying magically in this case. So put parentheses there. Does that change anything?
No.
Okay, so OCaml actually does the currying automatically. I didn't know that. I thought you would have to put parentheses there. Cool. Cool, cool, cool. Receives that.
Hmm. Oh, this is backwards. That's the problem.
Ah, yeah, that makes more sense. Okay, okay, you made it. This is the type of f. You remove the parentheses now from 105, just for us to see that it's still working. Yeah, it
It
does
does.
automatically the curry. Okay, I was wrong. Now go down there and see if anything changed. Doesn't seem to be. Run the Dune build. Don't trust
I
LSP at all.
just I just did.
Okay, so we
Hmm.
don't know how this is happening then. Awesome. We don't know why this type of header is parser state and not something else.
What happens if I do the thing that I wanted to avoid?
What's the type of header?
This is a parser state,
It does work.
and this has the correct type. So what the
What's
heck?
up with that? What's up with
Guys,
that?
I want to see the X files.
What?
I want to see what's the X files.
But this is still red,
I
actually.
don't know what you're talking about, Magit.
The mystery, well, like what's going on.
Ah, yeah, so let me explain. So, look at line 487. 487, we are running a parser called func.
Okay.
The at with the double arrow is a fish, so just like, this is monadic, so this means that the errors are being propagated properly, doesn't matter.
Okay.
But without using the function capture, which is what we were using before, you have to expose the state of the parser as a lambda. What Marin wanted is to have a way that you can have an auxiliary function that keeps the piping of state hidden from everybody else. But for some whatever reason that was not working. Yeah, so what's the type of header on that? Oh, didn't work, right?
No, it's red. It infers that the header is a parser state, but it isn't.
Yeah, okay, no, but do Control Z so I can finish my explanation to Magit. Yeah, that. Yeah, perfect. Yeah, this actually compiles, which is still mind-blowing. Okay, so you line 47, you parse a functor. Cool. Then you monadically compose that with another lambda that grabs what we just parsed, which we're calling header, and the remaining state of the parser. The problem is that Marinho wants to avoid exposing the state both in a lambda and piping it back into like more parsers, right, manually, as 488 does. So we created a function called capture that essentially does that for us automatically, as you can see there on the right. The problem is that changing this version to the capture version is changing the type of header, and we don't understand how and why. It doesn't make sense.
What about? Well,
And
try annotating. You can
doesn't work.
annotate
Annotating the types doesn't work. We already
from
tried that.
top to
But
bottom.
here's another thing that bothers
Or
the shit out of me. Look at 476. It is using the strategy. At
470.
double arrow, capture, and then a lambda with the thing that we just parsed. We are
Oh no,
using the
but
same
wait.
strategy down there.
But wait, the return is different.
No, no,
So
no. Show the type of ret, Marin, in there. This is
what is it?
what we parsed. In this case, is a parser clause based with location. Doesn't matter. But you don't have to deal with the state yourself, which is the
Yeah.
point. But in 487, header, as the code is written right now, is a func with location. Show him. See this? Func with location.
Yeah.
If you change this lambda to the capture version, header is changing the type. Why?
Headers change. What?
Remove 488 as well. Yeah, that. Yeah, now show him the
Yeah.
type of header.
See, the header now is a parser state for some reason, which is wrong.
Which is wrong, yeah.
Oh, isn't it the precedence of the operators with the func and
We already
They
did
all associate
parentheses.
to the right, yeah.
on the at?
Yeah, if we do this, it doesn't matter.
Doesn't matter.
Strange.
The mystery of the century. How is the version with the exposed state working and type checking properly? And again, and you know what's worse? Oh, but you also undid the capture on 490, right? You also are doing that on 490.
Yeah, because if I do this, it also breaks.
Man, I don't understand what the fuck is going on.
Actually, it doesn't.
Oh, it doesn't. Okay, so the second use case of capture works. What's the type of body there? Yeah,
It is
list of
correct.
parser clause, which is what we want. But on the beginning, it doesn't work. What's up with that?
I blame Marinho.
Why?
I don't know. Just gotta blame somebody.
Well, but at least
Don't
this
you
unblocks
normally
us.
don't you normally blame Lemos though?
Yeah. But this time I'm changing.
Okay,
He's changing
that's
his
fair.
verdict. Anyway, so this unblocks us. We don't know what the fuck is happening. This doesn't make sense. But at least we can implement top level now, so we can like we can finish the parsing. Okay, so now we just need to do top level, and we're done. We are done. Well, we're done with parsing. We still have to do the error handling, which we are avoiding for ages.
1 second, let me see. If it's a holds, we skip white space and comments and we parse the directive.
Yeah,
And then we do this.
yeah. If it
And
doesn't
then the
have the holds,
directive,
then we try to parse queries or declarations, and then that's it.
yeah. And then the directive,
We parse a functor first, which is the header.
we parse a functor first. We
Then we
skip
skip a
white
white
space.
space and comments. We open a curly brace. Then we parse it as if it was top level things. And then we do that until we reach a right curly brace. And at that point we are done.
Right curly brace. We should probably do this here as well, actually. Actually, should we?
Well, sure, why not? I think we should.
Yeah, we're actually missing something else here. We also need to find a period. And then we return.
Yeah. Okay, so now it's just a matter of implementing top level. So top level is essentially a bunch of if then else's, right? Just like expression.
Actually,
Oh no, you already did that with parser clause. So it's just a bunch of parser clauses then.
actually, we're handling the period up there, so we don't need it here. Never mind. Hmm. Yeah, we're probably undoing this after we deal with the locations properly, but for now, this should work.
Yeah. So what about top level? What is a top level? It's just a bunch of parser clauses, right?
Yeah, a top level takes a state, and it's a list of um, parser clause, but we have start delimiter, which is skip white space
And comments,
and comments. We have a separator.
which is the same thing.
We have a separator, which is in fact the same.
Then we have the thing itself. Well, the and is also the same. And then we actually do parser clause. Then we have to convert the finger tree back to a list.
Yeah, mapl, batch, finger tree.
Isn't it enough just to do like a normal, like one arrow bind and then replace?
One arrow bind and then replace.
That's what we've
One
been doing
arrow bind.
before.
That should work, yeah.
Okay, so now it's just a matter of calling the top level, right? In the parser parse prime.
Top level.
Does this build?
Sure does.
Okay, so the question now is can we, like, we're not doing error handling at all anywhere, which means that it's gonna just explode in our faces with no reporting because there's no handling for the syntax errors. But this should be already pluggable into the existing compiler, right?
Not quite, because the types don't really match. This returns a result, but the existing compiler, I think, just throws an exception and always returns when it returns.
Um, yeah, that's true.
I mean, we
Uh,
can do that. Oh, actually, top level needs.
okay, what?
Yeah, actually, this can't just be a top level. This needs something else. This needs also, and this is a very small, subtle detail about peg parsing. We need to make sure that this is the entire file, actually.
What do you mean?
So we have a not, right? We do.
I don't understand what you mean by guarantee that this is the entire file.
Um, capture file, one file, and this should be like this. Um, yes, then we need to check that this is in fact the end of the file. So we have
Your
to
parser
do
could succeed
not
on partial input, so you need to make sure you've got the EOF. I see.
succeed and then return file. Okay. It is not.
This takes two
Um,
arguments though.
This does take 2 arguments. It takes a parser, which is this. Ah, right, I added another argument for them to make the types work out nicer. This takes
An
a
A.
function to handle the error how you want. And it returns another parser.
Let's put a dummy lambda there then for now.
Fun. Yeah, this is going to return units, so that doesn't matter. It's going to return a location. I guess we can just do, oops, unexpected EOF.
No, wait, it's the opposite. Expected EOF and got something else, right?
Fun. Okay, so what's the issue?
Next matches value.
Ah, right. This is in fact
Oh, okay. Not curried. Well,
curried.
curried, yeah. Okay, so now it's just a matter. Okay, let's do the following. On sure. On 414, just do exit one. We're not gonna do any error handling, so just exit one and then remove the OK from 513, so we can have the same answer as the normal thing. Yeah, this is not gonna break. This is not gonna compile though, because the type signature of parse. Oh, we didn't put the outcome. Okay, now go to the executor and let's swap parse for parse prime.
Mm. One of them takes an extra string though. What's the
Which is
difference?
the executor already has that in the take into consideration.
Oh, right. We need to turn the input channel. We have to take everything, turn it into a string. Okay.
Yeah, the
So
executor already has
executor.
that. Yeah, so it's essentially line 9. You put prime, and then you put ink, I believe, as the second argument. What's the type of ink?
It's an int channel. Actually, we need to do
You need to read this thing, this guy.
int channel dot input all. That's what we need
Does
to
this
do.
compile?
It does.
Okay. Um, there's a problem though. Because the module system is halfway baked, we cannot run a program anymore, can we?
Can we? That's a good question. Well, we can print the output of the compiler as we were doing before.
I don't remember where I was doing that. But maybe in main.ml we were doing that? Not anymore. Okay. I have no idea.
Like, we can print these forms, I think, right?
We can print the forms, that's true. I just don't remember how, but we should be able to.
Forms is a finger tree.
Yeah, I have to convert that to a list.
Which we're already doing here, so... Oh, we're doing it here already, actually.
Okay, so try to compile a program.
Dune, exec, Karuta, compile, examples. Let's do good old plus, why not?
Something is wrong and we don't know where.
You know what we can do, in fact, is... If we go to the If we
Awesome.
go here, we're just doing exit 1, right?
Yeah.
Let's do 11. Let's, yeah, this is what we're hitting, which means this is failing.
Which means that something's wrong. I don't think there's a way around this. We have to error handle now to debug the parser. What's up with that? What is that?
That's wrong. Error is not a list. Uh,
Only those? I was expecting way more.
it's because when you do an if then else or when you do a choice, you actually discard all of the errors from everything except the last one, the last option.
But that still doesn't explain why we have so little errors on the top level, though.
Hmm.
My understanding is that we should fail as we encounter something. Like the first error we encounter, we stop. So we should have all of them on the top level.
That's not how that works, Lemos.
Okay, so that's wrong. We should change something to make that happen.
No, 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 no. Because here's the thing. How do you decide whether to parse a query or a func or a definition, a declaration?
Well, you parse some parts of it, and if you parse them properly, you continue. That's how it should work.
That's
Should work.
that's not how that works, Lemus. You try to parse a query. If it
Which is what I.
succeeds, you commit to that. But if that fails, you instead try to parse a declaration, and the error that you get here actually doesn't matter.
No, but that's still okay. That doesn't that doesn't contradict what I said because this is more this has the information if you fail anyway, right?
It does, but the point is that the error type of this gets discarded. Only the error type of this will be the error type of the entire if then else.
Wait, so if you're saying that if what if you fail on the else too? You're gonna use the else branch's information to report that?
Yes.
Hmm,
Um,
that sounds like a problem.
okay, here's the type signature, Lemos. You see this ET here?
Yeah, I see. No, 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 no. I believe you. It's we are returning the error information of the else branch. But that's again, that seems incorrect because even though you explained it to me and now I understand, we are losing useful information.
Are we?
Yeah, because if we are not matching the errors down there, where are we matching them? Like,
We aren't actually.
but that's
Most of
wrong.
the it isn't.
Yeah, I don't understand. If we are suppressing errors, we are losing error information in the middle of the process because we cannot differentiate between, oh, this is an error, but I have another choice here, slash, this is an error that should be reported. How is this not a problem?
How do you get around it?
Well, I thought last time we did this on Tuesday and Monday, on Monday actually, that we would bubble up all of the errors to the top level to do the logging for them. That's what I understood back then. But now, it's very clear to me, given the if then else, that we are actually not doing that at all. Because there is a very high chance that you're going to suppress error information because you cannot differentiate between those two occasions, right? Of like, oh, this is a fail of a choice, so I have another thing to try. Slash, this is a fail, but because none of the choices is going to work, I should keep that information to report it later. Because there's no way to separate those cases, we are losing it regardless. So the
Well, the
question now
separation
is,
is the else branch is kept always.
yeah, but that's still losing information, right? Because you're losing the previous error. And then the question still begs the question, what are we going to do about the errors that happens in the middle?
What are we gonna do about the errors that happen in the middle?
In the middle of the process of attempting, right? Because choices, these if then else or choice, they're about attempting and parsers, right?
Yes.
I don't get why do the errors that happen in the middle matter? Because they matter because we need to inform them differently. That's why they matter. If there is an error that should have a particular error message and we cannot match on it to use the logger on top of it, that means that we may encounter errors that will not have a good error message. That's why it matters. So what are we gonna do?
So what are we gonna do? Um. Well,
What
first of
errors do
all,
we currently have?
these ones.
Expected end of file, expected lowercase. So this is probably for what? This is for atoms and for functor names and predicate names. Unexpected end of file, which is very useless in terms of reporting, and wrong character, which I don't remember what that is for.
That can pop up if you're like if you're expecting, for instance, a question mark at the end of the query, right? But you get something like a pipe.
Which information are we holding? Only the location for that one?
No, we are also returning the
Ah, okay.
expected character.
Okay, at least that. Yeah. So one option that I could see is that we make the payloads for the tags for the errors a little bit more useful, so we can have better messages using them. So for example, the expected lowercase, is that for a functor? Is that for a predicate?
Um, that would be for the label of a functor, because it cannot start with an uppercase letter.
Okay, but we're not gonna differentiate them between functors as data and predicates.
Well, if you see a functor as data, that's an expression, which means actually it can be uppercase, but then that's a variable instead.
No. But then that's gonna have a cascading effect that the brackets won't make sense, right? If you were expecting
No,
something
then that's
lowercase and you had something uppercase, but that
no,
was a
then that's
functor
gonna bubble up.
originally.
No. If that happens, Lemos, that's gonna bubble up a wrong character because you're gonna match a variable, and then you're gonna see probably an open square bracket after that, right? After the variable.
Mm-hmm.
But you would probably be in a list of arguments of another functor, whether that be a predicate call or an actual functor being used as data or whatever. Which means actually you were expecting a comma, but you found a square bracket instead, you see?
Okay. Okay. Okay, so what would you do, Marinho, right now? We have only 4 cases, but the parser can fail many times in between. Everything is being funneled up to 4. What would you do?
What would I do?
We have the option of having bad syntax errors, just like a bunch of unexpected characters, a bunch of like we don't tell you anything meaningful aside from something is wrong in this character.
Uh,
Syntactically, right? Syntactically.
we could, like, we have the location where the error occurred, right?
Yeah.
And we also have the original string right here, right?
Also, yes. What's your plan?
So if you actually want good error messages, what you could do is say, okay, I'm going to look at the location. I'm going to look around that location, specifically before the location, and see what I find. But
Whoa.
that sounds
Expensive.
like it would go not expensive, but it would take some doing. Let's put it like
Expensive.
that.
I think the compiler implementation would get worse because of that. Because we're kind of doing a double pass in a sense. We already went through that. We put a marker there, but the marker is not detailed enough, so you have to go back to it.
Hmm.
Well, for now, just for the sake of making it work, we can do pattern matching on the 4 tags. Then we do some prints just to see what failed. And we have the location. The problem is that this location is only half of the useful location, right? It's only location.t and not location, the real location.
Uh, oops.